Our perfect star, the Sun, sits right at the center of our solar system. It's a star, a giant ball of hot gas that gives us light and warmth. This star, well, it's the reason we have life on Earth. It provides the energy for plants to grow, which in turn feeds almost every other living thing. The Sun's energy drives our weather, creates our seasons, and keeps our oceans from freezing into solid ice. It's a stable and consistent source of power, perfectly positioned to nurture a world teeming with life. For billions of years, it has been our constant companion in the vast, dark expanse of space. The Sun is a yellow dwarf star, a very common and stable type. Its gravity is the invisible force that holds our planet in a steady, predictable path. This orbit keeps us at just the right distance, a region known as the Goldilocks zone. In this special zone, it's not too hot and not too cold for liquid water to exist on our planet's surface. Water is the key ingredient for life as we know it. Our Sun's gentle nature and long lifespan have given life on Earth the time it needed to evolve from simple cells into the complex ecosystems we see today. But what if this perfect balance was suddenly shattered? Imagine, in an instant, our familiar Sun vanished, and in its place appeared something else, something much more extreme. The universe is filled with cosmic giants and strange stellar remnants, each with its own unique and powerful nature. Replacing our Sun with one of these celestial objects would trigger a chain of events so catastrophic that it's hard to fully comprehend. Our familiar blue sky, our warm days, and our very existence would be thrown into chaos, leading to a new and terrifying reality for our small, fragile world. This thought experiment takes us on a journey through the cosmos, exploring the most dramatic what-if scenarios. We will look at what would happen if our Sun were swapped with 6 different types of stars. Media group, lineup of different types of stars in space: red giant, red dwarf, blue star, neutron star, magnetar, black hole. 6 distinct stars appearing in space and at stock at a distribute underscore equally: a bloated red giant, a tiny red dwarf, a brilliant blue star, a dense neutron star, a magnetic magnetar, and a mysterious black hole. Each swap would bring a unique and devastating end to our world. By exploring these possibilities, we can better appreciate the delicate cosmic dance that allows life to flourish and understand just how special our own star truly is. Let us imagine the first swap. Our Sun disappears, and in its place, a red giant star materializes. The sky would instantly transform into a terrifying, blazing canvas of orange and red. This new star would be enormous, appearing not as a distant point of light, but as a massive, fiery wall filling a huge portion of our view. A red giant can be hundreds of times larger than our Sun. Its sheer size would be overwhelming, a constant and horrifying reminder of the planet's impending doom. Its surface, though cooler than our Sun's, radiates such immense energy due to its size that it would be like living next to a colossal furnace. The effect on Earth's temperature would be immediate and catastrophic. Within moments, the heat would become unbearable. The atmosphere would heat up by hundreds, then thousands of degrees. The world's oceans, lakes, and rivers would begin to boil violently, sending massive clouds of steam into the superheated air. This steam would trap even more heat, accelerating the process of planetary sterilization. The ground itself would begin to melt, turning rock into glowing rivers of lava. All the ice at the poles would vaporize in an instant, contributing to the runaway greenhouse effect that would seal Earth's fate. For life, there would be no escape. The sudden, intense wave of heat would incinerate everything on the surface. Plants, animals, and people would be vaporized in a flash. The very air would become a scorching inferno, and the water a boiling cauldron. There would be no safe place, not even deep underground or at the bottom of the sea. The planet would be scoured clean of every trace of life, its complex biosphere erased in a matter of hours. The world we know, with its green forests and blue oceans, would become nothing more than a charred, molten rock. The orbit of Earth would also be tragically altered. A red giant, despite its massive size, has often lost some of its mass as it expanded. If this new star had less mass than our Sun, its gravitational pull would be weaker. Earth would no longer be held in its tight, circular path. Instead, it would begin to spiral outwards, away from the star. But this would be no escape. The red giant is so large that its outer layers would already be expanding past where Earth used to orbit. Our planet would not drift away to safety. It would be swallowed whole, consumed, and dissolved within the fiery depths of the giant star. Destruction rating 9 out of 10. Perfect. Now let's consider a different fate. Imagine our sun is replaced by a red dwarf star. These are the most common stars in the universe, but they are very different from our own. Looking up, the sky would become a deep, permanent twilight. The new star would appear as a small, dim, reddish-orange dot. It would be so faint that you could stare directly at it without hurting your eyes. The world would be cast in a perpetual dusk, never truly dark but never bright. The familiar warmth of sunlight on your skin would be gone forever, replaced by an encroaching, unstoppable cold. The change in temperature would be swift and devastating. Without the sun's powerful energy, Earth would rapidly begin to lose heat to the cold vacuum of space. Within a week, the average global temperature would plummet below freezing. Within a year, it would drop to a life-shattering -73 degrees Celsius or -100 degrees Fahrenheit. The oceans would freeze over, starting from the surface and gradually turning into a solid block of ice miles thick. The planet's water cycle would grind to a halt, rain and snow would cease, and the atmosphere would become incredibly dry and thin as water vapor freezes out of it. Life on Earth would face a slow and agonizing extinction. Photosynthesis, the process that powers most life, would stop almost immediately in the dim light. Plants would wither and die, and with them, the foundation of the entire food chain would crumble. Animals would starve and freeze. Humans might survive for a short time in specially built shelters, perhaps powered by geothermal or nuclear energy, but it would be a grim existence on a dead world. Only the hardiest of microbes, living deep beneath the surface near volcanic vents, might stand a chance of surviving in the planet-wide deep freeze. The planet's orbit would not be safe either. A typical red dwarf is much less massive than our sun, sometimes having as little as 1/10 of the sun's mass. This weaker gravitational pull would not be strong enough to hold Earth in its current orbit. Our planet would begin to slowly drift away from the tiny star. Over years and centuries, Earth's orbit would become wider and more elliptical. Eventually, our world would break free from the red dwarf's grasp entirely and become a rogue planet, doomed to wander alone and frozen through the endless darkness of interstellar space. Destruction rating 4 out of 10. Let's swap our sun for a cosmic powerhouse, a brilliant blue star. These stars are rare, massive, and incredibly hot. If one appeared in our sky, the world would be bathed in an intense, piercing blue-white light. The glare would be so bright that it would be impossible to look at the sky without being instantly blinded. The light would have a harsh violet tint, and it would be accompanied by a flood of invisible but deadly radiation. The sky itself would seem to shimmer with raw energy, a beautiful but lethal spectacle that would signal the end of everything. The temperature on Earth would skyrocket to unimaginable levels. A blue star can be thousands of times more luminous than our sun, pouring out a torrent of energy. Within minutes, the surface temperature would climb past the boiling point of water. Within hours or days, it would reach thousands of degrees, high enough to melt rock and turn the entire surface of the planet into a sea of magma. The atmosphere would be superheated and stripped away by the star's ferocious solar wind and intense radiation, leaving the planet naked and exposed to the full force of the star's fury. Under this onslaught, life would be annihilated in an instant. The sheer brightness would be enough to cause fatal burns in seconds, but the real killer would be the radiation. Blue stars emit vast quantities of high-energy ultraviolet rays, X-rays, and gamma rays. This radiation would sterilize the planet, destroying the DNA of any living organism and tearing apart the molecules necessary for life. Nothing could survive this cosmic blowtorch. The planet would be burned, irradiated, and melted into a lifeless, glassy sphere, a testament to the untamed power of a blue star. Interestingly, the fate of Earth's orbit would depend on the blue star's mass. If we were lucky enough to get a blue star with the exact same mass as our sun, our orbit would remain stable. Earth would continue to circle the star at the same distance and speed. However, this would offer no comfort. We would simply be trapped in a stable orbit around a star that was actively destroying our world. Mars, further away, might warm up, but it too would be bathed in the same deadly radiation, rendering it completely uninhabitable. Any hope for survival in the solar system would be extinguished. Destruction rating 5 out of 10. Imagine a far stranger scenario. Our sun is replaced by a neutron star. This object is not a star in the traditional sense. It is the super dense core left behind after a massive star explodes. In the sky, it would be a chilling sight, absolutely nothing. A neutron star is tiny, only about 20 kilometers across. and it emits very little visible light. Earth would be plunged into a profound and permanent night. The moon and other planets would vanish from sight, as there would be no sunlight for them to reflect. The only light would come from the distant stars of the Milky Way, shining in a cold black sky. Without any light or heat from a central star, Earth would freeze. The process would be identical to the red dwarf scenario, but even more complete. Temperatures would plummet, oceans would turn to ice, and the atmosphere would freeze and fall to the surface as snow. The planet would become a silent, icy tomb. However, this deep freeze would be accompanied by a hidden danger. Neutron stars, especially young, rapidly rotating ones called pulsars, are far from quiet. They are cosmic lighthouses that sweep powerful beams of radiation across space. These beams are made of intense X-rays and gamma rays. As the neutron star spins, these beams would wash over Earth with terrifying regularity, perhaps multiple times a second. Each pulse would be a blast of deadly radiation. On the surface, this would cause skin burns, radiation sickness, and certain death for any life that hadn't already frozen. This radiation would interact with the upper atmosphere, creating spectacular planet-wide auroras. The sky would light up with shimmering curtains of green, purple, and red light, a beautiful, deadly light show in the eternal night. If the neutron star had the same mass as our sun, our orbit would remain perfectly stable. This is a key concept in gravity. The pull of an object depends on its mass, not its size. So our dead, frozen, irradiated planet would continue its journey around the tiny, invisible stellar corpse as if nothing had changed. It would be a ghost solar system, with frozen worlds orbiting a dead star. The combination of extreme cold and lethal radiation makes the neutron star a particularly insidious threat, killing the planet in two different ways at once. Destruction rating, 7 out of 10. Okay, let's take the neutron star scenario and turn up the danger to an extreme level. Now, imagine we swap our sun with a magnetar. A magnetar is this special, super rare type of neutron star with a magnetic field that's just, well, it's beyond anything we can really comprehend. We're talking trillions of times stronger than Earth's magnetic field and thousands of times stronger than a regular neutron star's. Just like a normal neutron star, it would be tiny and basically invisible in our sky, plunging Earth into cold and darkness. The planet would start to freeze over, with the oceans turning to ice under a starless sky. But honestly, the cold would be the least of our worries. The magnetar's colossal magnetic field would be the real agent of our destruction. As soon as it appeared, its magnetic forces would reach across space and slam into Earth's own protective magnetic field, the magnetosphere. This shield, which normally protects us from solar wind and cosmic rays, would be instantly overwhelmed. It would get compressed, twisted, and maybe even ripped away from the planet entirely. The results? Catastrophic and immediate. Power grids and satellites would be fried by induced currents, plunging our technological civilization into darkness. Without its magnetic shield, Earth would be totally defenseless. The magnetar's own radiation, mixed with the raw influx of cosmic rays from deep space, would bombard the surface. But the magnetic field itself would do even more damage. It would pull on every atom on the planet, especially those with magnetic properties, like the iron in our blood and in the planet's core. Even scarier, the immense magnetic forces could actually rip our atmosphere right off, sucking the air away into space and leaving the surface in a vacuum. Life would be wiped out by freezing, radiation, and explosive decompression, all at once. Even the very structure of our planet could be at risk. Magnetars are known for these things called starquakes, which cause them to release monumental bursts of energy. A powerful starquake from a magnetar at the center of our solar system would release a gamma ray flare that could hit Earth with the force of like 1 trillion nuclear bombs. This blast would be strong enough to literally crack the planet's crust and boil away whatever's left of the atmosphere and oceans. In this scenario, Earth's orbit would probably stay stable if the mass was the same, but the planet itself would be utterly and completely destroyed by the invisible, irresistible force of magnetism. Destruction rating, 8 out of 10. Alright, so our final scenario is maybe the most famous and honestly the most feared cosmic object, a black hole. Let's be specific and say our sun is replaced by a black hole with the exact same mass. There's this common misconception that a black hole is like a cosmic vacuum cleaner, sucking up everything around it. But really, that's only true if you get very close to it. From our distance of 150 million kilometers, we'd actually be perfectly safe from its gravitational pull. Our orbit wouldn't change at all. Earth would just keep circling the black hole, just like it circles the sun. The view from Earth, though, would be, profoundly eerie. The black hole itself would be completely invisible, a perfect patch of blackness against the blackness of space. It would be incredibly small for a solar mass object, only about 6 kilometers in diameter. You wouldn't be able to see it with your naked eye, but you could detect its presence with a telescope. As it passed in front of distant stars or galaxies, its immense gravity would bend their light, a phenomenon called gravitational lensing. This could create strange distortions, multiple images, or even a perfect Einstein ring of light around the black hole's position. Just like with the neutron star, the immediate problem for Earth would be the lack of light and heat. With no star to warm us, the planet would start its final journey into a deep freeze. The temperature would drop to hundreds of degrees below zero. Life would just stop, and the planet would become a ball of rock and ice. There would be no light, no warmth, no energy to keep the complex chemistry of life going. Our vibrant, colorful world would become a dark, silent, and frozen wasteland, drifting in the cold emptiness of its own solar system. The black hole scenario is, well, a silent and cold death. There's no fire, no blinding light, and no deadly radiation, unless matter falls into the black hole, creating a bright accretion disk. But in our stable solar system, that's pretty unlikely. It represents a different kind of terror, the terror of absolute nothingness. The source of all life and energy would be replaced by a void, a point of infinite density from which nothing can escape. Our planet would survive, physically intact but utterly dead, forever orbiting a tiny patch of impossible darkness. Destruction rating, 6 out of 10. So, we've journeyed through 6 scenarios, each one offering its own unique and a pretty terrifying fate for our planet. Every cosmic object brings its own brand of destruction, turning our life-giving solar system into a total death trap. Let's compare these apocalypses for a second. The red dwarf and the black hole scenarios are, partners in cold. They both plunge Earth into a deep freeze, killing life through the slow, creeping absence of heat. The black hole is just a little more destructive because its end is more absolute. There's no faint light, no tiny source of warmth, just an endless cold night. On the other end of the spectrum, we've got the fiery deaths brought by the red giant and the blue star. The blue star is a fast, brutal killer, incinerating the planet with intense heat and radiation. It's a quick and violent end. The red giant, though, is even more destructive. It doesn't just boil and melt the planet, it actually physically consumes it. Earth wouldn't just be sterilized, it would be completely vaporized and basically assimilated into the star itself. That's a total and complete annihilation of our world, leaving not even a charred rock behind. The neutron star and the Magnetar offer, more exotic and terrifying ends. They combine the cold of the black hole with intense, deadly radiation. The neutron star freezes and irradiates the planet at the same time, a pretty cruel combination. But the Magnetar adds another layer of horror with its absolutely mind-boggling magnetic field. It doesn't just kill life, it actually attacks the very fabric of the planet. It can tear away our atmosphere and magnetosphere, fry our technology, and maybe even shatter the crust with its starquakes. So, it's a more complex and thorough destroyer than a regular neutron star. Each scenario really highlights just how finely tuned our existence is. A star that's too big, too small, too hot, too cold, too dense, or too magnetic would spell our doom. We live in this delicate balance, a cosmic sweet spot that's let our planet stay habitable for billions of years. Swapping our sun for any of these other objects shows that, the universe is full of forces that are not friendly to life. Our sun isn't just a light in the sky, it's the perfect celestial engine for our world. So after weighing all these catastrophic possibilities, which star swap would actually be the most dangerous for planet Earth? The blue star would melt us, the black hole would freeze us, and the neutron star would irradiate us. Each one is a world-ending event. But one scenario really stands out as the most comprehensively destructive. An apocalypse that leaves nothing behind. That scenario is the red giant. While other stars kill life and make the planet uninhabitable, the red giant goes a step further by completely destroying the planet itself. The red giant's danger comes from its sheer overwhelming size. Its expanding outer layers would physically engulf Earth. There wouldn't be any frozen rock or molten sphere left orbiting where our world used to be. The planet, with its entire history, Its mountains, its core, and honestly, the dust of everything that ever lived on it would be swallowed and dissolved into the plasma of the star. It's the ultimate destruction, an erasure from the cosmic record. No other scenario, except maybe being torn apart by a Magnetar starquake, guarantees such a complete and utter annihilation of the planet itself. The Magnetar comes in a close second for the title of most dangerous. Its ability to destroy through multiple vectors, cold, radiation, and magnetism, makes it a truly terrifying object. The fact that it could rip our atmosphere away and shatter our crust makes its destructive potential almost equal to the Red Giant's. But the Red Giant's fate is just more certain. It doesn't just damage the planet, it eats it. That makes it the undisputed champion of destruction in our little thought experiment. It's a fiery final end with no possibility of any remnant surviving. Ultimately, this whole cosmic exploration teaches us a pretty profound lesson about our place in the universe. Our sun, a stable and unassuming yellow dwarf, is our steadfast guardian. It's the perfect star for us, giving the gentle, consistent energy needed for life to emerge and thrive. The cosmic giants and stellar remnants we've talked about are amazing and honestly, a little terrifying, but they're also reminders of just how violent and extreme the cosmos can be. We should look up at our familiar sun with a renewed sense of wonder and gratitude because it's the anchor of our existence in this vast and sometimes dangerous cosmic ocean.